We hot. This is properties of trapezoids and kites notes. In this unit so far, I've covered the parallelograms. On your flow chart that we did, or that we looked at when we first started, uh, we did all stuff down the middle. The parallelograms, which would be the rectangles, rhombus, and the square, all of those are considered to be parallelograms. Now today we've got to do the trapezoid, which includes the isosceles trapezoid, and also on the other side the kite, which is its own thing entirely. We're doing those today. All right. The non-isosceles trapezoid, just a regular trapezoid. You see it out here to the right. Uh, Properties of a trapezoid. Only one pair of opposite sides are parallel. Only one pair of opposite sides are parallel. That's what makes this a trapezoid and not a parallelogram. Remember, on a parallelogram, both pair of opposite sides are parallel. Only on this one, just parallel here and here. These two sides right here are not parallel to each other. That's what makes this a trapezoid and not a parallelogram. That's the main difference. Uh, the other one is consecutive angles are supplementary. Y'all know what supplementary means, 180. But on here, the main difference too, I want to show you. Let me zoom in a little bit and show you this. With your consecutive angles, since only one pair of sides is parallel, you got to think of these two sides that are not parallel as transversals. And let me highlight them for you. You got to think of this as a line right here, and as a transversal. And this one on the other side, you got to think of this as a transversal. This is stuff I've already taught you, parallel lines and transversals. The reason I'm saying that, it's only consecutive. Like these two angles right here, which will probably be right angles the way this one is. This angle and this angle would be consecutive on this transversal. They're both 90, so they would add up to 180. And on this transversal over here, this acute angle right here, and this obtuse angle at the top right here would be consecutive. They would add up to 180 this way. But it wouldn't be 180 this way, like down here at the bottom. These two would not add up to 180. These two right here would not add up to 180 either. Only this way and this way on this one. That's the main difference between this and the parallelogram, which I showed you, all last week and yesterday too. It's only consecutive here and here, not all the way around. Uh, that being said, keeping that in mind, let's solve some problems using non-isosceles trapezoid, just a regular trapezoid. Given the measure of angle DAB is 62 degrees. The measure of angle CBA is 31 degrees. They want the measure of angle C and the measure of angle D. Ruiz, how would you find the measure of angle C? 180 minus 31. And I'll wait on y'all. 149. On the other side, uh, Kira, how would you find the measure of angle D? 180 minus 62. Yeah, 118. All right. Number two, find the measure of angle QRS. QRS, it's this angle right here. We need to find the measure of it. To find the measure based on what they gave me already, gave me an expression on Q and an expression on R. We need to write an equation first to solve for X. Miss Rivers, what equation would we write? Say it again, louder. Thank you. Consecutive angles right here, supplementary. Combine like terms. After we get X equals 10, they want angle QRS. Y'all should know which one we plugging back into. What you got, Q? Yeah. That's why I'm showing it to you. It's easy. We usually skip it, but this stuff ain't hard. We usually skip it because we be running out of time, but we got plenty of time because unfortunately we so far ahead of the other groups. Isosceles trapezoids. So these are the trapezoids that are isosceles. Y'all know what isosceles triangles look like. The best thing I can compare it to is an isosceles triangle. They got the top cut off of it. When you cut the top off of an isosceles triangle, you get an isosceles trapezoid, and then you'll have a flat surface at the top and at the bottom. That's what it looks like. The properties. It has the same properties of a non-isosceles trapezoid. Those two that I already talked about. One pair of opposite sides parallel. They're showing you that. And then consecutive angles are supplementary. So the consecutive angles on the left and on the right would be supplementary. The thing that makes it isosceles is these next four characteristics, properties. Non-parallel leg sides, or the legs, are congruent. So the two sides that are not parallel here and here, they're congruent. That's what makes it isosceles. The other thing, the diagonals are congruent. This time the diagonals inside are congruent to each other. The base angles are congruent. And we talked about base angles when we did isosceles triangles. But since you got two bases on this one, you got base angles at the top and the bottom. I got base angles up here, got two base angles here, and I got two base angles down here. The base angles will be congruent. And the last thing, this is a new property, it says opposite angles are supplementary. So saying angles opposite each other are also supplementary. Reason being because your consecutive angles are supplementary on here, and then your base angles are congruent. So let me show you one. This might go over some of y'all head, but some of y'all might catch this. So just based on what we did up top here, Ruiz, if I tell you this angle right here is 120 degrees, what's this angle at the bottom right here have to be? 60, right? Yeah. Well, they're saying since it's an isosceles trapezoid, the opposite angles are also supplementary. Because if this is 60, this will have to be 120 over here too, because these two angles are congruent. So they're the opposite angles on this one are also supplementary. And the same thing down here at the bottom. If this is 60, this has to be 60. But that means 120 and this opposite angle right here are supplementary as well. It's only on the isosceles trapezoid. I'm just trying to show you the properties. I think some of y'all caught that. If I can get 40% of y'all to catch it, I'm good. Ain't that major, but I just want you to understand why they're saying that on this one. All right, let's apply some logic. Number three, if ABCD is an isosceles trapezoid, so they are telling me it's isosceles trapezoid. Find each missing angle. Based on them telling me it's an isosceles trapezoid, I should know some things about it. But Darian, based on what they gave me an expression on angle C and an expression on angle D. What equation would you write to solve for X? Yep. I keep telling y'all it's a common sense class. Don't be scared to use it. X equals 13. After that, they want us to find all four missing angles. That shouldn't be hard for y'all. Let's start with angle C and D. I'm waiting on y'all. Yeah. Should plug back in. You should get 53. After that, Evangeline, what you do to get angle A and angle B? All right. Thank you. When I tell you your practice is just like the stuff I'm showing you on here, so you should have no problem if you're paying attention. If EFGH is an isosceles trapezoid, uh, EH is 4x minus 27. FG is x plus 9. EG is 3y. I'm saying all that. I might as well label as I go. EH 4x minus 27. FG x plus 9. EG 3y plus 19. And then FH, I'll write it up here. 11y minus 21. Hey, y'all see what's going on. Tonight, what's my equation to solve for x? All right, solve it. Say some rooms that we got to solve for y too. Braden, what equation are you going to write to solve for y? because I'm recording, I ain't gonna say nothing. But what equation will we write to solve for y? You gotta talk louder than that, bro. You sound like you asking me, but yeah. Yeah, I'm just trying to get y'all to use some common sense, man. They gave me both diagonals. Mm-hmm. 8y, 21, 19, add 21, add 21, 8y, 40, 8y by 8, y equals 5. Yeah, yeah. That's the trapezoids. Show you the kites. Yeah, it's one of the things we usually skip, but we shouldn't skip. It's not hard. Oh, oh yeah, I ain't done with trapezoid yet. I forgot. I gotta show you mixed segment there. I lied. Um, also on the trapezoid, we have what we call the mixed segment of a trapezoid, and they have a theorem for that. The mid segment of a trapezoid connects the midpoints of the legs. Showing you this out here to the side, you got a trapezoid, and then they throw a mid segment in. The reason I know it's a mid segment is because of these markings on each side here. They're showing me that this little half segment right here and this half segment are congruent. So they're showing me DE is congruent to AE right here. And on this side, they're showing me BF is congruent to CF. If that's the case, this is in the middle on each side. This is called a mid segment. If that's the case, we can find the length of a mid segment on a trapezoid if we needed to. It's not hard to do. I'm gonna show you with simple numbers first, and then I'm gonna give you the formula to help you understand it. All we're doing is taking the average, just like when we did what was the midpoint formula. It's gonna be the same thing. It's just we're doing it on segments now, and we're gonna have expressions instead of just simple numbers. For example, like if I just gave you numbers on here and not expressions like they do on the problems, you could do mid segment very easily. It's kind of common sense with just numbers. For example, say I tell you the length of AB is 6, and then I tell you the length of CD or DC is 10. If EF is going to be a mid segment, what would it have to be? Use common sense. Y'all about to blow your own mind. If EF is in the middle, what would it have to be? Holy crap. What's in the middle of 6 and 10? What's wrong with y'all? We on video right now. Y'all embarrassing yourselves. To even figure that out, though, you just taking an average. Like when we did midpoint before, all we would do is take the two values and add them together and divide by 2. Like this is literally just doing this 6 plus 10 divided by 2. 6 plus 10 is 16 divided by 2, 8. That's mid segment. That's midpoint. That's essentially what we're doing, except we're going to do it with expressions. So the mid segment formula. So on this one it says EF is the mid segment of a trapezoid ABCD. Then I edited this too. I had too many lines here, but y'all gonna have the old, I don't edit it now. But the formula would be my base at the top AB plus uh, DC divided by 2 equals my mid segment EF. AB plus DC divided by 2 equals EF. And that's essentially what I just did over here with a 6 plus 10 divided by 2 equals what EF was, which was 8. But we're going to use expressions, but we're going to take that same concept and apply it to solve the expressions. Very easy concept. Don't let it blow your mind. For trapezoid, PQRS, Y and Z are midpoints of the legs. Find YZ. So in this one, they want me to find YZ, my mid segment, but it's an expression there, so I got to solve for X. So I'm gonna still do the mid segment theorem to write my equation. I'll write the first one for you because I don't want to hear nothing crazy. The first one is gonna be my RS, my base. It don't matter which base you use first. I always put my shorter base in front. It don't matter though. So X plus 14 plus my other base, which will be the big one, 38 divided by 2 equals the mid segment. In this case, my mid segment is 5x minus 19. Once you write it out correctly, it's just solving an equation. And once again, I harp on this all the time, but I just want to remind y'all, this is why it was so important for me at the beginning of the year to show y'all how to reteach y'all how to solve equations. I'll make sure y'all knew. It's going to carry you through this whole year. That's the thing that most of y'all still struggle on, that are having trouble in this class. Those who aren't, I mean, you just know how to solve equations now. Times 2, canceling it over here, doing it on this side, times 2. When I do it on this side, I'm basically distributing here and here. So I'm going to rewrite my stuff. I'm bringing down x plus 14 plus 38 equals, I'm going to do my distribution over here. 2 times 5x is 10x. 2 times negative 19 is negative 38. Once you get to this point, it's just an equation. Y'all should be able to solve this. Combine like terms over here. X plus 52 equals 10x minus 38. Subtract x. Subtract x. 52 equals 9x minus 38. Add 38. 52 plus 38 is 90. Equals 9x. Divide by 9. X equals 10. That's all well and good, but they ain't asking me to solve for x. They asked me to solve for yz. So once you get that, you need to plug back in. Since I feel like this is gonna be the hardest one for y'all, because it's a new formula I'm giving you. Not really, it's just midpoint formula. It's just exaggerated a little bit. Do number 6, find KJ. Use the midpoint formula first, solve for midpoint. All right, well, use the midpoint formula to solve for x. I'm talking midpoint formula, mid-segment formula. Let me say it correctly. This ain't midpoint. Same thing, though. Mid-segment formula. Solve for the mid-segment. And then after that, plug back into whichever one they want you to plug back into. I started it back. Oh, I guess so. Oops. Am I starting? Yeah, I'm rolling. Are we back? All right. Yeah, we got x equals 5. Then after that, we just need to plug back in. Uh, Plugging back in for KJ should have just been 6 times 5 minus 1. I think must have got 29. All right. Properties of a kite. Last one, the kite. A kite is a quadrilateral with the following properties. There's actually one missing too. I'm about to talk about that one individually. But it has 4 properties. I don't know why. That's something else I need to edit on here. Okay. Uh, exactly. 2 pair of consecutive congruent sides. This is the main thing that makes it a kite. Uh, and if you look out here to the left, the kite that they're showing me an example of, what they mean by 2 pairs of consecutive congruent sides, you got 2 sides right next to each other that are congruent here and here, and then you got another pair of sides that are congruent here and here. This is what makes this a kite and not a parallelogram. The parallelograms, uh, you got sides parallel here and here and here and here. That's not the case on the kite. You've got a pair of consecutive congruent sides here and a pair of consecutive congruent sides here. To name them, side AB is congruent to side AD, and side BC is congruent to side DC. The next property of a kite: one pair of opposite angles are congruent. Only one pair of opposite angles are congruent. And on here you can see which pair it is. The pair of opposite angles that are congruent on the kite would be angle B and angle D right here. Angle B will be congruent to angle D. Then they say the diagonals are perpendicular, which they are. Diagonals are perpendicular, so the two diagonals, side AC or segment AC, is perpendicular to BD. Anytime you got perpendicular diagonals, y'all know what's in the middle. And they're showing you one right there. It's kind of faint, but it's right angle. She got all right angles in the middle. The other property that's missing, these two other angles here, A and C, they're not congruent to each other, but they are bisected by this diagonal right here, AC. It bisects these angles. So like uh this angle at the top up here, angle A, it'd be split in half congruently here and here. I'm using 2 markings. And then the one at the bottom here, C, it would be split in half congruently. I'm using 3 markings. That's the piece that's missing. So just to put a number on it, I'll do it on this side where I got a little more space. Say they told me angle C was 50 degrees. I'll automatically know the two halves are 25 degrees here and 25 degrees here. So you got bisectors on those two angles. All right. Keeping that in mind, let's do number 7. Find some missing angles. They want us to find the missing angles on here. We don't have to go in order. Jonas. Uh, And we don't have to go in order. Only reason I'm starting here because it's just the most logical place for me to start, I guess. But what's angle 7? Huh? Say it again. Oh, I set you up for the win, bro. Go ahead, Joseph. What's angle 7, bro? Say it louder. 52 degrees. I set you up to win, bro. Uh, it's the next easiest one. I would say angle 4 Sierra. What? Say it again. 65. And I'm not going in any specific order. I'm just going where I would go. You can go whatever way you want to go. After that, I probably just start doing 1, 2, 3 because those are the easiest ones to take out right there. So I'll do one next. Mike, how about I find angle 1? Teach me something. Mike, how about I find angle 1? All right. Vernon, how about I find angle 1? Yes, you can. So Vernon recognizes that this is a kite. It's a 90-degree angle right there. 180 minus 90 minus 65. What you got? Huh? Vernon, what's angle 2? Say it again. Say no trick, girl. What's angle 2? Exactly. What's angle 3, Vernon? 90. I'm done with you. Find somebody else. Move tonight. I'll just be itching to call you all the time. Sorry. Marley, how would you find angle 5? You know what, Mike? We're going to give you redemption. How'd you find angle 5? Yep. I'm listening. All right, Mike. So what's angle 6? Moving on, children. If AC is 38 and ED is 41, find CD. I ain't gonna lie, on these kites, when they start giving you these little diagonals and stuff, more than likely, they set you up to do what we've been doing in the last couple of days. So what I would do, and you can do it however you want to do it, but when they start giving me these numbers, like, so for AC, they said it was 38. Instead of writing 38 in here for AC, I'm gonna go ahead and do my splits because I got a feeling I'm gonna have to split at some point anyway. What's half of 38? Say it again. 19. So 19 and 19. I'm gonna write that right there for AC. I'm gonna write 19 on one side, 19 on the other side. So A to E is 19, E to C is 19. I'm just go ahead and do that. ED, which is not the whole diagonal, it's just this piece right here. They say that's 41. So I'm gonna write that in right here, 41. Okay. After that, they want me to find CD. CD, it's this side right here. Don't act like you don't know what's coming. Kaylani, what should we do to find CD? Talk louder. Pythagorean theorem. All you gotta do is label correctly, so you do it correctly. Slanted side is C. A, B. 19 squared plus all that one squared equals C squared. 19, 361. 41, big number, but don't be scared. 1,681 equals C squared. Add those two together. 2,042 equals C squared. Square root. Square root. We round it to the nearest tenth still. Say it again. 45.2. So CD equals 45.2. All right, I'm done with y'all. Do some work. Act like you learned something today.